Welcome to a lesson with Dr. Powell. Let's take a look at some more examples with sine x over x going to 1 as x approaches 0. So suppose you have the limit as x approaches 0 of maybe 2x over sine of 5x. What would this be? Well, we could think this is equal to the limit as x approaches 0 of, we could just write down 5x over sine 5x and then make a correction so it really is 2. What do you have to multiply 5 by to get 2? Well, it's just 2/5. All right, so notice that if we just kind of modified that into a 5x, it's the same thing. As 5x goes to 0, x goes to 0. Replace this with u, then this looks like the limit of u over sine u as u goes to 0. Not you personally, and I'm just kidding. Okay, times 2 over 5. Then what do we get? Limit as u goes to 0 of u over sine u times 2 over 5. This is just so taking the limit of the reciprocal of something is just the reciprocal of the limit. So this is just be the reciprocal of 1, which is just 1 itself still. So that means this whole limit is simply 2/5. Okay, let's look at another example. What if we had limit as x approaches 0 of sine of 2x over sine of 4x? What would this be? Well, let's do the following. What if we just think about what we know? We'd like to have a 2x associated with that, and we'd like to have a 4x associated with this. But what's the trade-off? Notice that you have x and x. This is like having a 1 over x over a 1 over x, and those would cancel. So introducing the x is fine, but the 2 and the 4 are another thing to reckon with. So putting down a 2 here would require is like putting a half in the numerator up here. So you put a corresponding half in the denominator to counteract it. Now putting a fourth in the denominator here, we put a fourth in the numerator to counteract it. Now you have equality. So if you put that 1/4 and 1/2, there it is equal. And notice that 1/4 is precisely 1/2 of a half, which means that this part, 4th divided by a half, is simply just 1/2. So we get 1/2 times this thing, which will go to 1, and this thing, which will go to 1. So we end up just getting 1/2 as our limit. Thanks for watching.